Today we will discuss the calculation of relative molecular mass. To clarify right away, the mass of molecules is calculated in the same way as the mass of atoms relative to 1/12 of the mass of carbon-12 isotope. However, there is a slight difference in how we calculate the molecular mass for different compounds. When we refer to substances composed of molecules, we use the term relative molecular mass and denote it as Mr. of the given compound. In summary, the molecular mass is determined relative to the mass of carbon-12 and varies depending on the compound being considered. But there are compounds consisting of particles ions, then we speak about the relative formula mass, which consists in relation to compounds consisting of ions. The designation of this value also goes as Mr. Let us explain how such masses are calculated. Let's take the formula of the compound CH4. This compound is called methane. It's an organic substance. It's made up of molecules. What atoms is this compound made up of? It's made up of one carbon atom and 4 atoms of hydrogen. Now let's explain the masses of each element. So it turns out that we have to have 1 unit, 1 carbon atom, its mass multiplied by the AP of the element carbon. And then add to that value the mass of 4 atoms of hydrogen. Let's do the calculation. So we calculate it like this. The result is 1 multiplied by its mass, 12 to the nearest 1 digit after the dot, plus add 4 multiplied by the mass of the hydrogen atom to the one. The result of the calculation is that we have 16 is the relative molecular mass. Of course, when you do such calculations in large quantities, it is not always necessary to write them out each time in this way, so you can make the calculation shorter and write it down in a more compact way in order to simplify it. In a more compact way to simplify the situation. So let's calculate what the mass of sulfuric acid will be equal to. This is also a compound made up of molecules. So we multiply the mass of hydrogen, which is 1, by the number of atoms of this element by 2. Plus we add the mass of 1 sulfur atom, multiplied by its mass, and then we add the mass of 4 atoms of oxygen, multiplied by 16. The result is a mass of 98. But the result I have obtained is the result of an integer value. Sometimes for such calculations it is necessary to show the calculation more accurately. I will give another example of a compound that is made up of molecules. This would be the compound glucose. Glucose has the formula C6H12O6. So how would its mass be calculated? Well, we need the mass of carbon 12 multiplied by its number of atoms by 6 plus the mass of hydrogen. Multiplied by its number of atoms, 12, and the mass of oxygen. Multiplied by its number, 6, and the result is a mass of 180. So, how the calculation of compounds made up of molecules is done, I think is clear. Now let's calculate the relative mass formula for compounds of ionic character. Let this be the compound magnesium, OH, twice, The compound is called magnesium hydroxide. What ions does this compound consist of? It's made up of one magnesium ion with a charge of 2+ and two ions, charge minus. Now, what will the added masses of atoms consist of? That would make it 1 multiply one magnesium ion by its magnesium R, plus then we add 2 OH ions multiplied by the AR of oxygen plus another AR of hydrogen. So now we're going to calculate this compound magnesium, OH, twice. So for magnesium it's 1 times 24. And 3 if we take it precisely, plus 2 times 16. And plus 1. The result of our calculation is 58, 3.3. The calculation we have shown is accurate, but surely you can calculate and make such a calculation much more quickly without having to unpick each of the parts and from each of the steps to simplify the situation. It would be NH4 twice SO4. This compound is called ammonium sulfate. And the calculation would look like this. Inside this bracket, we have nitrogen and hydrogen multiplied by 4. Outside the parenthesis, we have 2 times 2 plus. Then we're looking at gray 32 plus oxygen, 16 times 4. This calculation yields 132. Once again, I emphasize, sometimes such calculations should be made more accurately for calculations. And if this is a necessary condition, then you can take the relative atomic masses of each element from the periodic table with the number of digits after the dot that are presented in the periodic table. I'll explain, for example, for oxygen. If we take oxygen, its mass expressed in the periodic table looks like, to be precise, 15999. 5. And then, if there is a need, the calculations are carried out with as many digits as there are after the dot. This, as a rule, is stipulated in the assignments, with what necessity, with what precision this calculation is carried out. So please be careful. Read the assignments in order to answer very correctly. Goodbye.